Hello, Mrs. Peachy's WCA physical science class. So I'm doing a video tutorial here for you today to kind of explain a bit on what you need to do for your acids and base portfolio. So as you can see, you have a portfolio that's due here this week. And the one that's in the lesson, I did not like that one. So I have actually skipped that for you. So you won't be doing that portfolio. That doesn't mean you're not going to be exploring acids and bases. It just means that you're not doing this particular portfolio. So while you're not doing this, you do have a custom lab that I'm going to be adding to the gradebook. And if you don't have that completed, it goes in as a 0. So make sure you're actually completing the portfolio, even though it will not show up on your to-do list. So just make sure you make a note that you have to complete the portfolio that I'm going to be sending out to you, even though it's not on the to-do list, okay? So what do you actually need to do for this portfolio? Well, that's what we're going to talk about today. Okay, so we're going to be talking about what you need to do. So the first thing I'm going to draw your attention to is just our physical science website. Now, if you're not familiar with the physical science website, you must have been sleeping all year. So you need to make sure you get familiar with that pretty soon. The link for this should be found on our message board. That's your section message board. Click that pinkish purple colored push pin icon in the upper right corner of your screen to access it. Might be blue, so they change depending on the student version versus the teacher version, but it's a push pin icon. I also always have a link to my website in my email. So anytime I send you an email, there should be a link in my signature. When you get there, you're going to be at the home page, which looks a little different. So you're going to want to select physical science at the top of the screen to get here. When you scroll down, you'll see portfolio information, and here's the stuff from Unit 1, Unit 2, and Unit 4. Those are the 3 portfolios you've done so far. So now you're going to be doing Unit 5. Now there will be a video here. That's what I'm making at the moment. So there's no video showing at this time, but that's going to be coming. That's what you're watching right now. And there's also a worksheet. So you're going to want to pop this out. Go ahead and hit the pop out here. Open that up. And you have 2 options here. You can either open this with Google Docs, or you can download this to your computer and open it in Microsoft Word. If you don't have Microsoft Word, Google Docs is a great option. If you do have Microsoft Word, that's probably preferable because Microsoft Word is what you have to upload it into at the end of the lab. But again, if you don't have it and you open it in Google Docs, this is now going to be your own version here because it's going to convert it to a Google Doc for you, so you don't have to save as or create your own copy or anything because you should be having access to this. If for some reason you don't, then you'd hit make a copy, okay? But when you're all done with this, you're going to then download it to your computer as a Word document, which I can then see and open. You could also download it as a PDF or something like that. But somehow you have to save it to your computer as one of those 2 options so that I can then view it when you upload it to the Dropbox. All right, so this is called the Red Cabbage Chemistry Worksheet. And on here, we're going to be doing a couple of different things. We're going to start off by doing some red cabbage chemistry. And then we're going to be doing a little virtual titration as well. So those are the 2 things we're going to be doing, and that's what I'm going to be going over with you during the video. So if you read a little bit about red cabbage has a pigment inside of it called flavin, and flavin is found in many different fruits and stuff like that. It gives it kind of a purpley red color, and you can extract this out and pretty simply. We're going to show you how to do that here. And it can be used as an indicator. And what an indicator does is it changes colors to then tell you if your solution is an acid or a base. And it kind of gives you a range of colors to then tell you whether you have a very acidic solution or just slightly acidic and that kind of stuff. That's what this type of indicator is called. This is called a universal indicator because a universal indicator will indicate for all different kinds of pH. Some indicators will only go red and blue, just acid base. But this one indicates kind of a whole rainbow of different colors, right? So you can do 2 different things here. You can just watch the video that I'm going to show you, or you can actually make your own red cabbage indicator. So if you follow along with the directions in the video, you can make your own red cabbage indicator and you can experiment on your own substances. The ones we are going to be doing are muriatic acid, vinegar, aspirin, vitamin C, club soda, salt water, baking soda, laundry detergent, ammonia, and drain cleaner. So those are the different things that we're going to be looking at today. But if you wanted to do this at home, if you want a hands-on thing, you can buy a head of red cabbage, make your own indicator solution, and then come up with household items kind of similar to this. If you can find these, that's awesome. If you want to substitute, if you don't have muriatic acid, for example, and you want to substitute something else in there, that's okay. That's something that's kind of dangerous to use, actually. So if you do use that, make sure you have the proper safety precautions, goggles and gloves, and do that, standing up at a kitchen counter or something like that. But you can also substitute something else in there, like lime or lemon juice. That would be probably a good substitution in that situation. Some sort of a citric, something that's clear. So lemon or lime juice is fairly clear because you want to be able to see a color change. Okay. So go ahead. We're gonna, if you have or you want to do this on your own, just pause the video and gather your ingredients and get your red cabbage going and stuff like that. And then you can come back to this later. But let me just kind of walk you through with the video how to do this. And if you don't have any of this materials, you can just watch the video and you can take the data down. Okay, you can always rewatch this part of the video and take the data down later, but you're going to note the color and then you're going to go back and you're going to look at this chart and you're going to compare the color of the solution to the chart and find out what the pH number is, 1, 2, 4, 6, 8, 10, 12, 14. If it's in the middle, let's say it's kind of a not quite purple, but not quite indigo, you can pick the number in the middle, like 7. Right? So if it kind of falls within the middle here, if you have a greenish yellow, you might want to pick 13 here, right? Or a bluish green, you would pick 11. So you're going to want to, there's a range in there as well. And then you're going to decide whether it's an acid, a base, or neutral. So acids are between a 0 and a 7, and a base is between a 7 and a 14. The 7 itself is neutral. So if it's kind of halfway between purple and indigo and you think it's a 7, then you would consider it to be a 7 for pH, and that would be neutral. Okay, so we're going to do that part first. Let me go ahead and bring over the YouTube video that we're going to watch right here, and I'm going to narrate this one for you. So I'm turning the sound off because I want to use my own narration because I talk too much and tell you too much stuff that I don't want you to know yet. I want you to figure out for yourself. All right, so what Lonnie's doing here is he's actually going to make the red cabbage indicator solution. He's taking a head of red cabbage and chopping some chunks of it off, right? And he's adding it to a blender with water. Just water. Hot water probably works the best here, though. So if the water's hot, that'd be better. And then he's just going to blend it up into a nice liquid puree, making a little juice, right? You don't want to drink this. It's pretty nasty. So get it as pureed as you possibly can. And then he's going to take this and he's going to filter it out. So he's using some filter paper. You can actually use a coffee filter in there or a couple coffee filters and let it run through. And the juice that comes out then has no chunks in it. But he's already done this before. So he's going to say, I've done this earlier. This is what I got earlier. Okay, so I'm going to pause it. So this is called the red cabbage indicator solution. He just did it. This was hot water. Again, the hotter the water, the darker purple you're going to get there. So you probably notice there's a hue difference here. This was a demonstration. This was done earlier. He probably did it under a little hotter water at that time. So that's how you get that. Now, if you don't have a blender or a filter paper, the other option for getting your red cabbage juice is just to boil red cabbage on the stove in boiling water and let it boil there for like 10 minutes. And then strain out the water, right? You want the water, so don't strain it into the sink, but strain it into a bowl. The water should be a deep purple color at that time. So you've boiled out what you want in that situation. So you can do that if you don't want to filter or blend. This is quicker, but that one is less materials to use. So now what he's going to do is he's going to add this purple red cabbage indicator into different solutions. He has muriatic acid here. He's got vinegar, aspirin, vitamin C, club soda, salt water, baking soda, laundry detergent, ammonia, and drain cleaner. And he has them in little clear beakers. It's kind of hard to see that, but they're all lined up in clear beakers and they're kind of backlit there. Well, then he has the ingredients that he used up on top so you can see it. So here's where you guys are going to observe the color, and you're going to then add that color to your data table. Okay, so I'll let him go ahead and start. And each one has a separate stir stick in it, a clear one, so that we're not mixing things together. It's actually a pretty cool little setup he's got going on here. No, ideally, I would say you'd want to make sure you added the same amount of indicator to each one. It looks like he's kind of estimating that, but he's not actually measuring it. So that's something to think about here. If you need to pause this to write down your observations, go ahead and do that. And again, if you can do this on your own, it's actually pretty cool to do. It's a pretty easy kitchen science one. Okay, so we can kind of see the different colors here again. Just go ahead and write down your observations. You can pause my video to do that. The different colors of each one of these, and you're going to put down the estimated pH. And then in the third column, if it's an acid or a base according to the scale. Okay? Okay. So hopefully you filled out all this information already once you paused it. And now you're going to answer some questions about acids and bases. You know, what other acids and bases do we encounter every day? Which of the results surprised you and why? And what other liquids are you curious about their pH value? Then we get to the second part, which is called the titration. And that's what we're going to be doing next. So I'm going to go ahead and try to find the correct window here. I'm sorry, guys. I always have way too many windows open. Let's see where it is. Where is it? It is right here. So here's our virtual titration. I also put the link on your worksheet. So if you wanted to do this one on your own, you could do that one too, just to kind of get an idea of what's going on. But let me just reload this one. This uses Adobe Flash, which unfortunately is not going to be available for very long because of some update they're doing this year. But I also could only get it to open on Google Chrome. I could not get it open in Firefox. So I am doing it for you. I'm not requiring you to do it yourself simply because it's not necessarily the best behaved app here, but it's actually pretty cool. So this setup is called a titration. And a titration is basically how you can figure out the concentration of an unknown acid or base based on a indicator reaction. So we kind of looked at a different indicator before. That was that red cabbage indicator. And a red cabbage indicator is a universal indicator. So that means that it has a bunch of different ranges that it can indicate for, right? Different color variations kind of gives you an idea of the actual pH. Well, this indicator we're going to be using is something called phenolphthalein. And phenolphthalein is kind of just a basic acid-base indicator. It doesn't indicate for, kind of doesn't give you that color variation. It just gives you either pink or clear. So when you drop phenolphthalein into a base, it turns a brilliant pink fuchsia-y color. It's really pretty, actually. But if it's not basic, it's just clear. And it doesn't matter how basic it is. The pink will kind of get darker, I guess, as it's more basic. But it's just pink. It's not going to give you any other colors at all, okay? The reaction that you're going to be using, or we're going to be mixing acid, hydrochloric acid, with a base, sodium hydroxide, and that is going to yield sodium chloride and water. This is a basic acid-base reaction or neutralization reaction. So the first thing you're going to do is you're going to actually balance this equation. I put a text box here for you so you can type into it. You're going to retype this equation. You do not have to put the little parentheses with aqueous solution or liquid here, okay? Just the equation itself, and then put the appropriate coefficients to show what a balanced equation would be, because this is not balanced at the moment, okay? So I know that takes you back to the last unit, but you should still hopefully remember how to balance the equation. Then what we're going to do is we're going to look at what a titration reaction actually is. So with a titration reaction, you are going to, you don't know what the concentration is of this acid. We know it's hydrochloric acid, but we don't know how concentrated it is. We do know the concentration of this base, sodium hydroxide. So it's called the standard solution because we're comparing this unknown acid to the known base. So the idea here is that with this type of acid-base reaction, there are hydroxide ions, OH, that come out of solution here, and they will exactly match the hydrogen ions that come out of solution here, okay? So let me give you an example of what I mean. I want to draw something for you real quick. I'm just going to open up this thing called a Jamboard, and we're going to open a new one real quick here, just to kind of give you an idea of what I mean, okay? So the idea here is that with my sodium hydroxide, the sodium splits off from the hydroxides, okay? And those have a negative charge. The hydrochloric acid, the hydrogens split off from the chlorines. Chlorines are negative, sodiums are positive, so they split apart. That's called dissolving or dissolution. What happens is these hydrogens are going to pair up with the hydroxides. They're going to find each other. They're best friends. They're going to pair up together. There's two H's and one O. Now this becomes water. The sodiums find the chlorines and they pair up with each other and they become salt. So remember that the products of this neutralization reaction are sodium chloride or salt and water. Well, for every hydrogen that bonds with a hydroxide, that is called neutralization. The hydrogens are neutralizing the hydroxides. When there are exactly the same number of H plus or hydrogens as there are hydroxide, the solution is neutral, completely neutral. If there's more hydrogens, it's an acid. If there's more hydroxides, it's a base. So if we have more of the HCl than we do the NaOH, then it's going to be an acidic solution. If we have more of the sodium hydroxide, the NaOH, than we do the HCl, it's going to be a basic solution. And when we have exactly the same of each, then the whole solution is neutralized. That's called neutralization, right? So with this setup, if I drop sodium hydroxide into the hydrochloric acid, if I get the exact same amount of hydroxide ions that I have hydrogen ions, the whole solution becomes neutralized. And the way we measure that is by looking at an indicator. So the idea here is this is an acid, right? So there's phenolphthalein in here. I'm going to put phenolphthalein in here. Phenolphthalein is clear with an acid. It only turns pink when we have a base. So if I add my phenolphthalein here, the solution stays clear. When I add my base to it, it's going to stay clear until the solution turns basic. So there has to be one more sodium hydroxides than there are hydrochloric acids in order for it to be a base. Okay, so going back to my Jamboard to kind of give you an idea of what I mean. If I have a bunch of hydrochloric acids, right, over here, a whole bunch of them, because I have a whole solution full of them. And I'm just going to give you an example. Obviously, there's way more than this. Okay, every time I add 1 drop of sodium hydroxide, one of them will match one of the acids. If I add a second drop of sodium hydroxide, another one matches another acid. And I keep doing this until, oopsies, sorry, messy writing. Each one matches, right? Then it's neutral. Guess what? It's still clear at that moment. But if I add just one more, now it's going to turn basic because it has no more of those acids to pair with. So now it's going to turn pink. So when we go 1 drop more than what's already there for the acid, then it's going to turn pink. So it's just at that moment where it turns pink that we stop. Because at that moment, we're just 1 drop over neutral. And that's pretty darn close to neutral. Okay. So let's look at what this looks like. I'm going to start adding drop by drop, and we're going to stop the second it turns pink. Okay. We're just going to go 1 drop at a time. It's really important to go very slow when you do this. Otherwise, you can overshoot very quickly. Oh, we went too far. Did it look like we went too, or it started turning pink, but it didn't stay pink. So let's still go, because sometimes that happens. It's going to go a little bit, and then it's going to go back. And that actually happens in real life. As it gets closer to it, it starts to, shift, but then the atoms kind of rearrange themselves, or the ions do, and then it's not quite there. And we're going to try that one more time, guys, okay? Because something went wrong. Okay. This is more like what I was expecting here. Oh, it went pink, didn't it? It went pink there. At 6:17, it went pink. All right, so it looks like we maxed out here at 18, but it went pink at 17. Okay, so it went pink at 17. So what we know is that it took 17 drops of our sodium hydroxide to turn our hydrochloric acid pink. And that is what a titration is. Now, there's some math that we can do, which I'm not going to have you guys do, that allows us to then calculate using that information how exactly concentrated that acid was to the beginning. Okay. So we already looked at number one, right? It took 17 drops for it to become pink. And so you need to answer the questions number two. Phenolphthalein is an indicator that changes to pink. Remember, is that when it is exposed to an acid or a base? And question three, this is kind of the whole point of a titration. Why does this help us determine the concentration of the acid? So think about that Jamboard that I was showing you here for that one, okay? Think about how that Jamboard shows us as we're adding the base to the acid. At what point does it turn pink? And when it turns pink, like we said here, remember, what does that say about the pH? Now it's a base at that point, but remember, it's just a teeny tiny bit away from neutral at that point, okay? So hopefully that makes sense. Kind of explain a little bit about this whole situation about as you're adding the drops of base to the acid, it's still acidic until once it turns pink, we know that it's just at that point of neutralization. So it tells us pretty much exactly how concentrated that base is because it's going to match the concentration of the acid. Okay? All right, so then you're going to, once you have the balanced equation, answer those questions and then save this, ladies and gentlemen, and this is what's going to be submitted to me. Okay, so save this to me. You are going to have to email this to me in order to submit it because it is a custom assessment. So you're going to have to email this to me in order to be able to get it to me. Okay, that's the only way. There's no Dropbox for this one. I apologize. I said that earlier. You just email it to me, so you really don't have to if you're doing a Google form or whatever, Google Doc. You can just make sure you save the, update the permissions so I can view it, but you can just send me the link to that too. That works just as well. All right, so hopefully that made sense to you guys. If you have any questions or concerns, let me know. Otherwise, have a fabulous, fabulous day.